I'd like to take a few minutes and explain the accessory switch controller. There's actually two sides to the ASC. What we have is the support side, which is the power that runs the device, and the communications that actually provide the data from the command base to the ASC. The support side has two 4-position terminal blocks on it for the data and common line on the communication wire, and the power and ground on the for the power on the ASC. The business end of the ASC has a total of 10 terminals in the terminal block. The business end is what actually connects to the accessories or the switches, which we'll get into showing you how to connect them to all the various switches out there in just a few minutes. First, I want to cover the support end. The ASCs operate the best at 14 volts AC. So you want to provide power from your fixed power supply to the ASC. Now this is actually is arranged in what we call a daisy chain. We've got power and ground for the ASC itself. This goes to 14 volt AC hot, and this goes to the next ASC or series of devices in that series. So it could be a block power controller, an operating track controller, etc. The black wire is going to ground on your 14 volt AC accessory transformer. So we're providing power to the device to operate. We also use something called a serial data cable. These are available at any Lionel dealer. All that it basically is the RS-232 or the DB9 connector, which plugs into the front of the computer port on the command base or the legacy base. And it has two wires, a red and a green wire. Red is the data, green is the common. This common is not to be confused with this ground. So we've got red and green, red here, and we would put actually two red wires in here. One from the command base cable and one from a controller to controller cable, which I'll explain in a minute. And then also two green wires. These two are the command base cable, and these two go to DAT and COM on the next device, a BPC, OTC, ARC, etc. This is what we call daisy chaining. So we go from the command base to the first device, a COM and a data line to the next device over, COM and data to the next device, and so on and so on. We daisy chain the data and the common line for the communication. For the power, we do the same thing. We got 14 volt AC coming in. This A is connected to that A. This U connected to that U. So we put power in, power goes out to the next device, comes in, goes out to the next device, and so on. 14 volt AC in. These ASCs use virtually no power at all, so it's just very low current. This is providing the power for the ASC to operate. Now, the business end of it. It's a little bit confusing when you look at it, so let's explain it. We have 4O 4T, 3O 3T, 2O 2T, and 1O 1T. When we're using this in a switch configuration, what that means is this would be the straight arrow key on our cab 1 or legacy remote, and the same on all of these. I'm sorry, take that back. This is the diverging route here. The out is the diverging route, the T is the straight. Through is the straight arrow position or the straight position on the switch. Out is triggered by aux 2. And finally this out, through, and through. So we've got aux 2, aux 1, 2, 1, 2, 1, 2, and 1. The COM, the COMM, this is common. The reason it's blocked off like this is because this common is for these two switches only. And this common is for these two switches only. So what this means is, if we're running a twin coil machine that really triggers by throwing ground to one side or the other, we can put AC ground into this common and go out and through to one switch, out and through to the other switch. Let's say that the next two switches, they actually require AC hot going to the coil. We can put AC hot into this common and put the ground connection out at the switch and control AC hot for the out and AC hot for the through using the aux 1 and the aux 2 buttons. So this common for these two switches, this common for these two switches, and that's it. So if you put a common only in here and you connect all four switches, switch 1 and switch 2 won't work at all because it has nothing that it's throwing. And to understand the common and the through and the out is really very simple. This device has common coming in here. We have the out and we have the through. When you press the aux 2 button, it makes a contact between here to there. So whatever polarity is on the COM, AC hot or AC ground, it's connected here and the device does what it does. When you let off the aux 2 button, this goes away entirely and we're back to this configuration where there's no connectivity between any of these 3 points. You press the aux 1 button and it takes the common lead to the through position and the device does what it does. So we've got a common with 2 outputs, which would be out and through for 2 devices. Common for out and through on one device, out and through on another device. Then another common out and through for 2 more devices. And these commons, once again, are not connected internally. So it gives you a little more flexibility in what you're trying to operate. Now, if you're operating accessories, this common here is for these 4 accessories. This common here is for these 4 accessories. Same rules still apply. I can put ground into this common and control it on these 4 outputs, and I can put hot into this common and control hot on those 4 accessories. So a lot more flexibility with an ASC versus something like an SC2, where the SC2, the commons are connected internally. You only can put AC ground into the center pin. You cannot put AC hot in there, otherwise you'll have a short. Whereas the ASC, you can go ground and hot, or 2 grounds, 2 hots, whatever you need for whatever you're controlling, and you've got 2 outputs, through and out, and another 2 outputs through and out, based on whatever polarity you put into the COM.